Greetings, Professor McKee here with the next video in Seminar Saturdays. Today's paper is all about R&D, research and development. The paper is called Missing R&D, and my usual disclaimer that I'm going to mangle somebody's name. This is by Ping-Sheng and David Reeb. They published this in Journal of Accounting and Economics back in 2015. Just a few notes here. This was published in a top accounting journal. This is one of the best accounting journals out there. And accounting is a very closely related field to finance. We sometimes publish in accounting. They sometimes publish in finance. And we both use R&D expense a lot. R&D expense is widely used either because we're directly interested in investment in intangible assets like patents, trade secrets, and so on, or we want to control for investment in intangible assets. So this paper is really useful for anyone who's going to use R&D expense, which is a lot of people in both finance and accounting, and apparently management too. So, missing R&D. The issue here is that R&D expense is a very important accounting information. We want to use it. It's input into the production of things like patents, trade secrets, all that intellectual property. But a huge number of companies don't report their R&D expense. It's not that they put it down as zero. They put down nothing. They just leave it blank. The data is missing. Now, if you look at the accounting standards, the rules that the accountants are supposed to follow, they're required to disclose R&D expenditures. So if you're missing R&D, it's left blank, that must mean no expenditure happened, right? Well, as we'll see, no, that doesn't actually mean that. The authors do a number of tests and they show that the missing R&D firms are not the same in terms of intellectual property output as the firms with no research and development expense. Now, this missing R&D is a problem, is a major issue. There's a lot of papers in accounting and finance and apparently management. I didn't know management used R&D so much as 42% who use it. And we don't agree on how to handle this issue. Really, there's going to be a correct way to do it or the best way to do it. So it'd be nice to know what that is. So accounting they just replaced with zero, at least before this paper. Finance, we would replace the zero and use dummy variables when we do that replacement. And management, they replace it with the industry average or historical average. So one question this paper is going to try to help us with is what approach is best when we're dealing with this data problem? How do we handle it and not lose half our sample of companies, because there's a lot of companies that don't report it. But first, they go in and show that actually this is a problem and just replacing it with zero is not the correct solution, which means accounting and finance are wrong. So the reason they do this is because we can see an output. We can see what happens when you finish your research and development, which is when you file a patent. Because patents are publicly filed, nowadays there's a lot of papers that have been using patent output as a measure of firms' output of intellectual property. And if you're filing and gaining patents, it's kind of hard to do that without spending money on research and development. So if you have no reported R&D, but you do have patents, that's a problem. So what they're going to task is they're going to say, well, if blank R&D is the same as zero R&D, so they're just doing no research and development into intellectual property, then their patent activity should be pretty similar, as in they should have very little patent activity. But if the blank R&D firms are actually doing some R&D and they're hiding it, maybe because they don't want to reveal information to their competitors, then their patent activity will be more similar to firms with positive R&D expense. And they also can look at patent characteristics. So are the quality of the patents going to be different or similar from comparing the blank R&D firms with zero R&D or positive R&D? And then the last thing they do is they consider if this is a reporting sort of issue. So if you are forced to change your auditor, because the auditor is one of the main people that sort of make sure you're following those accounting standards correctly, your new auditor might have different definitions of what counts as R&D expense, and so you might suddenly start reporting R&D expense if you switch auditors. If you're really not doing R&D expense, switching won't matter. You're not going to do it. But if you are doing R&D expense and your auditor's allowing you to report it as some other expense or whatever, then new auditor might change things. So they look at that too. Now, in terms of their descriptive statistics, they're basically breaking it down by the blank R&D firms, so these guys don't report R&D. The zero R&D firms, these are ones reporting zero as the R&D expense. And then the positive R&D firms, they reported some positive number as their research and development expense. And these are firm year observations, so each year for each firm we have one observation. Although most of the time, if you look at the data like I have, you'll see that this company will report no R&D expense in 2010. They'll also report no R&D expense in 2011. They'll have it blank many years in a row. Firms tend to be pretty consistent about how they report their R&D expense. At the bottom, we have the percentage of patent activity. Now, for zero R&D firms, the ones that affirmatively say we have no R&D expense, their patent activity makes a lot of sense. It's 1%. 1% of them out of these 10,000 observations have some patent activity going on. That's not very often. And it makes sense because they're not spending money on R&D. Meanwhile, if you have positive R&D expense, half the time you have some sort of patent activity going on. Again, pretty plausible. But something very damaging for thinking R&D expense being missing equals no R&D expense is what happens with the blank R&Ds. They have 10% of the time some sort of patent activity. And of course, we have other types of intellectual property we are not able to see. So this 10% is an undercount of how much activity is really going on. Certainly, this is quite different from the 1% of the zero R&D firms. But this is just a visual sort of eyeball check. Let's actually formally test it. So they first do some t-stats. And they look at a lot of different patent characteristics. So the number of patent applications, the number of patents that are granted by the patent office, some characteristics involving patent quality, and they find that the blank R&D companies versus the zero R&D companies have more patents, have higher quality patents. And this is whether they match the companies based on some bunch of firm characteristics that are listed down here, or if they just do the overall sample. So these blank R&D firms really are doing more patent output than the zero R&D firms. The patents are higher quality. There's a lot more of them. So this is pretty convincing evidence that they really are doing something. They probably shouldn't be putting zero as, or blank, or we probably shouldn't be putting zero for blank R&D firms. And they run some regressions using the same zero R&D versus blank R&D samples, and they find no shock, based on what we just saw. Blank R&D strongly predicts all sorts of patent characteristics, both applications and grants, as well as various quality characteristics. And this was using a matched sample of the zero R&D firms. Okay, so one of the main outputs of R&D, patents, is clearly higher for blank firms versus zero R&D firms. They have more patents, they have higher quality patents. Now, how do they compare with non-zero R&D firms, firms that report that they are spending money on R&D? Well, if you take a matched sample here, or the overall sample, these blank R&D firms do not produce as many patents as the positive R&D firms. It's quite strong. However, they are apparently producing higher quality patents, so smaller number but better on various metrics. Okay, we again have very strong statistical significance, but they're all positive here, so they're higher in citations, higher in generality and originality, better citation lagged, and better patent claims. Now, if you limit the positive R&D firms to only firms with patent activity in that year, then the patent quality goes away, and now you have fewer patents, and your patent quality is lower too. But clearly, these firms, while not producing patents at the same rate and possibly the same quality as these positive R&D firms, they're doing some work here. Now, let's look at our auditor shift here. Now, there does need to be some identification strategy going on here because we have a potential problem. Firms choose auditors, and therefore, if they choose to switch, the reason they switched might be also causing them to change their R&D expense. So since it's not the different reporting norms of the new auditor, it's the company's operations is different now, and now they're investing in R&D. But what if we had something where many companies are forced to change their auditor? It wasn't their choice. They had to do it. And we have a nice setting in the United States with Arthur Andersen. At the time, before Arthur Andersen collapsed, it was one of the big five, now it's big four, for accounting companies that are doing audits. Public firms overwhelmingly use the big five, well, now big four, auditors, so a significant number of our publicly traded companies are going to be suddenly forced to switch, which will include some blank R&D companies. Now, if these blank R&D firms are actually not doing anything that's even remotely close to R&D, this change shouldn't matter. They're not going to start reporting R&D expense if they are true zero R&D firms. Are just not bothering to report anything because it doesn't matter. But if there were some activities that were more borderline, and because of Arthur Andersen's particular approach to disclosures would put it under something different than R&D expense, the new auditor might disagree with Arthur Andersen, especially given that Arthur Andersen just collapsed because of a major accounting scandal. The new auditor is likely to put a lot of scrutiny on things like those sort of discretionary decisions. So in that case, these firms would probably switch to start reporting more R&D. They become positive R&D firms after their auditor switched. And that is indeed what happened for the firms with patent activity. So they're looking at, they call it pseudo-blank R&D firms. These are firms that had patent activity that year and reported a blank R&D expense. And then blank R&D firm is just, you didn't report R&D expense. So if you're a former Arthur Andersen client and you were a blank R&D firm with patent expense, you had a big increase in the probability of reporting non-missing R&D expense. It's actually a 6% increase. These coefficients here are not percentages. This is a logistics model, and the coefficients do not really tell us the increase in probability. Now, if you're a blank R&D firm and you had to switch because you're Arthur Andersen, no change. It was just the ones that were doing patent activity. And again, patent activity is about 10% of the blank R&D firm sample. So some of the blank R&D firms are probably not doing R&D, but the ones that are reporting patents definitely are. And we have some nice evidence here from the forced switch in the auditing company to support that claim, as well as just the simple logic of they're getting patents, so they must have R&D. Okay, so they've hopefully well established that yes, these blank R&D firms really do have something going on with R&D, What they do next is they do some simulation analysis to try and estimate what the best approach is to address this problem, because we don't want to just drop all firms. I mean, we can do that. I've done that as a solution, but replacing with something so we don't lose half our sample is kind of something we want to do, because again, losing half your sample is not great. So they have a whole bunch of different solutions that they're going to compare. There's the replace with zero or replace with zero plus adding a dummy variable, which accounting and finance were using. Replacing with industry average, which is what management was doing. They also include replace it with industry average and add a dummy variable, which is sort of a combination of what management and finance were doing. Replacing it with zero, adding two dummy variables, one for whether it has patent activity and one for if it's just blank overall. Replace with industry average and have a dummy for patent activity, and then replace with zero, include the number of patents as well as a dummy for blank R&D. A lot of different potential approaches here. We're going to see which ones improve the model the most. And what they found is that when you replace with industry average, the model improves the most. These ones also have a dummy variable for it's a blank R&D firm or it's a blank R&D firm with patent activity. And so their suggestion is that instead of replacing with zero, replace with the industry average. And it seems like the management approach, where you take industry average and use that instead of replacing with zero, is superior to just the replacement with zero. Definitely, we don't want to do zero replacement. That creates bias. There are a significant chunk of those missing R&D firms that are doing actual R&D expense, and if we're forcing them to all be zero, we are going to cause problems. And that is everything for this paper. It's a very nice short paper that's very focused on the interesting methodology problem that we face in finance and accounting. And so this is a pretty short video too. So there are non-trivial numbers of missing R&D firms that are actually doing R&D. If you're doing work and research, you shouldn't replace missing R&D with zero because it's not going to be correct. And again, a significant minority of these firms are not actually zero R&D firms. And, which is always good when you have a sort of methodology paper like this, they propose a solution, which is don't just drop them. What you mean, you could do that too. But take the industry average and then maybe add a dummy variable saying you replaced it. And that industry average replacement will give you the best estimate we can get for those firms that are hiding their R&D. All right, so that is everything for this week's video. Next week, I'm going to go back and start presenting a few more AFA papers that I saw back in January. I'll see you all next week.